What if I told you there's an engine so indestructible that UPS trucks routinely ran them past 800,000 miles without rebuilds? An engine that farmers swear by, that starts after sitting in a field for 20 years, that mechanics call virtually unkillable. This is the story of Ford's 300 cubic inch inline-six, the slowest, toughest, most underrated engine in American history. Picture this. It's 1978, and you're a fleet manager staring at fuel prices that just doubled. Your mechanics are drowning in warranty claims on complicated V8s. Your drivers are breaking down on rural routes where a tow costs more than the cargo. You need something that won't die, won't complain, won't eat you alive in maintenance costs. Ford has an answer, but it's not what anyone expects. The Ford 300 inline-six wasn't built to win races or grab headlines. It was built to outlive everything else on the road. And from 1965 to 1996, it did exactly that, powering millions of F-Series trucks, vans, and industrial equipment with a reliability that bordered on supernatural. This is how Ford created the most dependable engine in automotive history, by ignoring everything the industry thought it knew about performance. To understand why the 300 became legendary, we need to travel back to 1965. The muscle car era was exploding. Pontiac had just dropped the GTO. Ford itself was pushing 427 Cobra jets and Boss 429s. Everyone wanted cubic inches and horsepower numbers that looked good in magazine ads. But Ford's truck division had a different customer, the guy who bought one truck and expected it to last until his kids inherited it. The American truck market in the mid-60s was brutal. International Harvester dominated fleet sales with their indestructible inline engines. Chevrolet's Straight Six had a devoted following among farmers. Dodge was gaining ground with their Slant Six. Ford needed something that could compete not on a spec sheet, but in the real world, where downtime meant lost money and broken promises. Here's where it gets interesting. While Ford's performance division was chasing horsepower records, a small team of engineers in the truck division was given a simple brief: design an engine that could run 300,000 miles with basic maintenance. Not 30,000 like most engines of the era, not even 100,000, which was considered exceptional. 300,000 miles minimum. Their budget? Practically nothing compared to the V8 programs. The team, led by engineer Bill Burnett, started with a radical premise for 1965. What if we don't care about horsepower at all? What if we optimize purely for longevity and torque? The result was an engine that made marketing executives weep and mechanics smile. Let's talk specifications, because the numbers tell a story of deliberate choices. The 300 displaced 4.9 liters through a bore of 4.0 inches and a stroke of 3.98 inches, nearly square, which meant even cylinder wear and balanced forces. But here's the kicker. It used 7 main bearings to support the crankshaft. 7. Most inline-sixes used 4. V8s typically used 5. This meant the crankshaft was supported every few inches, eliminating flex and wear. The block itself was a monument to overbuilding, cast from high nickel iron with walls thick enough to stop bullets, literally, as some farmers discovered. The deck height was enormous at 10.5 inches, allowing for a long connecting rod that reduced side loading on the cylinders. Ford engineers specified a forged steel crankshaft when cast iron would have been cheaper and good enough. They wanted indestructible, not good enough. The cylinder head was equally robust. A single casting of iron so thick you could machine it multiple times without weakening it. The valves were modest, 1.77-inch intakes and 1.45-inch exhausts, but they were shrouded in hardened seats that refused to wear. The camshaft was mild, with just 0.396 inches of lift and 248 degrees of duration. This wasn't about breathing at high RPM, it was about generating massive cylinder pressure at idle. Now here's where Ford got clever. Instead of a timing chain that could stretch or jump teeth, they used a gear drive, direct mesh gears that would last the life of the engine. No maintenance, no adjustment, no failure point. Just mechanical perfection that would outlive the truck it powered. The oiling system was equally overbuilt. A high-volume pump fed oil through passages large enough to maintain pressure even with worn bearings. The oil pan held 6 quarts, more than many V8s, providing thermal mass and contamination dilution. You could run this engine low on oil, overheat it, and it would forgive you. Try that with a high-strung performance engine. But the real genius was in what Ford left out. No overhead cams to break, no complex valve timing to go wrong, no aluminum parts to warp or corrode, no electronic controls in the early versions, just a single-barrel carburetor so simple a teenager could rebuild it with a screwdriver and patience. The power output? This is where accountants cringed and engineers smiled. In 1965, the 300 made 170 horsepower at 3,800 RPM. By the 1970s, emissions regulations had choked it down to 114 to 120 horsepower, 114 horsepower from 300 cubic inches. Chevrolet's 250 straight-six made nearly the same power from 50 fewer cubes. The 300 was deliberately detuned for longevity. But torque? Torque was the 300's party trick. Even in its most strangled form, it produced 240-265 pound-feet of torque at just 2,000 RPM. Some versions peaked at 2,600 RPM, basically idle speed. This meant you could lug a fully loaded F-250 up a mountain in high gear without downshifting. The engine would just grunt and pull, never complaining, never overheating, just converting fuel into forward motion with mechanical sympathy. Let me put that in perspective. A modern Ford EcoBoost V6 makes its peak torque at 3,500 RPM. The 300 made maximum twist at half that engine. Speed. It was like having a diesel's pulling power with gasoline's convenience. The compression ratio was conservative, just 8.0.1 in most versions. This meant you could run it on 87 octane, even 85 in high-altitude areas. Some fleet operators ran them on cheaper, industrial-grade fuel. The engine didn't care. It would burn anything from premium unleaded to drain oil in an emergency. Ford offered multiple fuel options from the factory. The standard gasoline version was just the beginning. They built propane and natural gas versions for fleet operators. The conversion required different carburetor jets and slight timing adjustments. That's it. No special pistons, no reinforced internals. The same bottom end that ran on gasoline would happily burn propane for 500,000 miles. Industrial applications pushed the 300 even harder. Irrigation pumps ran them at constant RPM for months without shutdown. Generator sets accumulated 50,000 hours. That's nearly 6 years of continuous operation. Wood chippers, air compressors, welding machines. If it needed reliable power, someone bolted a 300 to it. The maintenance schedule was laughably simple. Change the oil every 3,000 miles, though many owners stretched it to 5,000 or more without issues. Replace spark plugs at 30,000. Adjust the valves never. The hydraulic lifters were self-adjusting. The water pump might need replacement at 150,000 miles. Maybe. Real-world longevity reports bordered on unbelievable. A 1976 F-150, owned by a Montana rancher, logged 1.3 million miles on the original engine, still running when he sold it. A delivery company in Texas had a fleet of 300 powered trucks that averaged 650,000 miles before retirement, not rebuild, retirement. They still ran. They were just too rusty to be safe. UPS became infamous for their 300-powered fleet. Their mechanics developed a saying, "The truck will rust away before the engine quits." They weren't wrong. UPS trucks routinely passed 800,000 miles with nothing but routine maintenance. When they finally retired them, independent buyers would snap them up knowing the engine had another 200,000 miles left. But here's the thing about the 300. It wasn't just reliable, it was forgiving, catastrophically forgiving. Run it out of coolant? It would overheat, sure, but let it cool and it would start again. No cracked heads, no blown gaskets. Run it low on oil? The bottom end was so overbuilt it would survive long enough to get you home. Forget to change the oil for 20,000 miles? The 300 would shrug and keep running, maybe a little noisier but still pulling strong. There are documented cases of 300s running after being submerged in floods, frozen solid in Alaska, and buried in desert sand. One farmer in Nebraska accidentally ran his F-250 on a mixture of diesel and gasoline for a week. The engine knocked like a hammer drill, but never stopped running. After draining the tank and refilling with proper gas, it ran another 100,000 miles. The 300's simplicity made it a favorite among mechanics. You could rebuild one in a dirt floor garage with hand tools, no special pullers, no timing lights, no computer diagnostics. The parts were cheap and interchangeable across decades of production. A cylinder head from a 1965 would bolt onto a 1996 block. Try that with any modern engine. Field repairs were legendary. Farmers fixed thrown rods with welding rod and JB Weld. Bush mechanics in Alaska rebuilt them using parts from 3 different dead engines. One documented case involved a 300 running for 2 weeks with a cracked piston. The owner just added a quart of oil every day until parts arrived. Performance enthusiasts discovered the 300's potential in the 1980s. With mild modifications, a 4-barrel carburetor, headers, and a cam swap, you could extract 300 horsepower while maintaining reliability. Some turbo builds pushed 400 horsepower from the iron block that refused to crack. The 7 main bearings that made it heavy also made it incredibly strong under boost. The aftermarket embraced the 300 with everything from aluminum heads to fuel injection conversions. Off-roaders loved it because the massive torque at low RPM was perfect for crawling. The inline configuration meant a low hood line for better visibility. And when you inevitably bashed it against a rock, the cast iron block just laughed. In 1987, Ford finally modernized the 300 with electronic fuel injection. The EFI system added maybe 15 horsepower, but dramatically improved fuel economy and emissions. More importantly, it maintained the engine's core virtue, simplicity. The injection system was basic, reliable, and fixable with ordinary tools. The EFI 300 could achieve 20-22 mpg in an F-150, remarkable for a 4.9-liter engine. Fleet operators calculated that the fuel savings plus reduced maintenance made the 300 cheaper to operate than smaller, theoretically more efficient engines that required more frequent repairs. By the 1990s, the 300 was an anachronism. Overhead cam V6s made more power from less displacement. Aluminum blocks reduced weight. Variable valve timing improved efficiency. The 300 was iron, pushrod, and fixed timing. A dinosaur in the age of mammals. But it was a dinosaur that refused to go extinct. Ford's engineers tried to kill it multiple times. In 1980, they developed a replacement V6. Testing showed it made more power, but couldn't match the 300's durability. Canceled. In 1985, another replacement program. The new engine was lighter and more powerful, but cost twice as much to build. Canceled. The 300 survived because nothing could match its cost-per-mile economics. The end came in 1996, not because the 300 failed, but because Ford needed the factory space for modular V8 production. The last 300 rolled off the line on December 30, 1996, ending a 31-year production run. Over 15 million had been built. Conservative estimates suggest half are still running today. Think about that for a moment. An engine, designed when Kennedy was president, using technology from the 1940s, remained in production through the advent of fuel injection, catalytic converters, and computer controls. It survived 4 decades not by adapting, but by being so fundamentally right that adaptation wasn't necessary. The 300's influence extends beyond its production run. It proved that simplicity and durability could trump complexity and performance in the right application. It showed that there was a market for good enough power if it came with exceptional reliability. Modern truck engines with 100,000-mile intervals between services owe their philosophy to the 300's example. Collectors now seek clean 300-powered trucks, knowing they're buying something that will outlive them. Restoration shops report that even barn-find 300s often start with just fresh gas and a battery. The engines that were too slow for glory have become too tough to die. There's something deeply American about the Ford 300, not in the flashy look-at-me way of a Mustang or Corvette, but in the quiet, get-it-done reliability of a lunch pail and work boots. It's the engine equivalent of a craftsman's hammer, not pretty, not fancy, but absolutely perfect at its job. The 300 reminds us that engineering excellence isn't always about pushing boundaries. Sometimes it's about drawing a line and defending it. Ford's engineers decided that 300,000 miles was their line. They exceeded it by factors most thought impossible. In an industry obsessed with next year's model, they built something designed to outlast generations. Modern engines are marvels of technology. They make more power from less fuel with fewer emissions than anyone in 1965 could have imagined. But they're also complex, expensive, and increasingly impossible to repair without dealer-level equipment. The 300 represents a different philosophy, that reliability is the ultimate performance metric, that simplicity is the ultimate sophistication. When Ford retired the 300, they didn't really replace it. They couldn't. You can't replace an engine that owners refuse to give up, that mechanics recommend to their mothers, that defines reliability for an entire industry. You can only succeed it with something different, something that solves different problems for different times. But out there, on farms and construction sites, in developing countries and rural communities, millions of Ford 300s are still working, still starting every morning, still pulling loads that would stress modern engines, still refusing to die. They're not fast, they're not powerful, they're not efficient by modern standards, they're just unstoppable. And maybe that's the real lesson of the Ford 300. In a world obsessed with the newest, fastest, and most complex, there is profound value in something simple, reliable, and permanent, something that does its job without drama or recognition, something that just works forever. What's your Ford 300 story? Have you owned one of these indestructible engines? Maybe you've inherited one that's been in your family for generations? Drop a comment below with your 300 experience. And if you enjoyed this deep dive into one of America's toughest engines, make sure to subscribe. We're just getting started exploring the engineering marvels that built this country. Until next time, keep those engines running, especially if it's a 300. Chances are, it'll outlive us all.